So I still have another 10 minutes, so I can spend another 5 minutes talking a little bit about AI and how AI could potentially be an interesting thing in the field, and then I will wrap up. Who in the room is using AI or ChatGPT for kind of asking questions or communicating? Okay, most of the people in the room are actually, and you are impressed, right? In terms of, oh my goodness, how kind of intelligent is the system in terms of processing the questions and providing information. It's just amazing to see how things are moving forward. Even I was showing Alex in today that we have a group of people that we are using a new platform that you give them some like 5 papers and ask the platform to just make a podcast from those 5 papers for 20 minutes, having 2 or 3 hosts. You can decide these two hosts are going to discuss those papers together and give you information. And the quality, I was just showing Alex the quality of those podcasts. You cannot imagine that it's just made by AI. It's just, and you hear there are some like really good kind of voices, radio voices that are interacting in that podcast. So things are moving very fast forward. But how these things are going to be a part of addiction medicine and innovation, things like that, and this is something that we definitely need to consider in the future. It's just, I think that emergence of AI and in these intelligent system is going to be even more groundbreaking than what we had with internet. And it's just going to revolutionize whatever we are doing. And independent of what we are interested to know, this is going to happen. And we need to learn how to use it and be ready for that. So there are a couple of terms in the field, like machine learning, deep learning, artificial neural network, large language models, foundation model, digital twin brains, ChatGPT. And people in the room, how many of you have heard about foundation models? Foundation models, okay, 3, okay, good. So let me just give you a very brief overview for a few minutes and wrap up. So when we talk about AI, artificial intelligence, one way of doing AI is what we call machine learning. So it is one way of AI is machine learning. And then deep learning is a type of machine learning that is in that kind of category. And then for deep learning, we have mainly artificial neural networks that are doing deep learning. And foundation models are specific deep learning tools or with artificial neural networks that are specific to specific areas. For example, what we call LLM, and LLM stands for large language model, right? So ChatGPT is a large language model, so foundation model that is specifically trained for text and videos, right? So this is called large language model. They are trained by language, and ChatGPT is one of them. But there are specific foundation models that are designed to see things. They are called vision models. So they can see, so you can just give them videos and tell them how many cars are here and how many things are happening. They are designed to see things. They are vision models. There are audio models. They can make new songs from singers that died 50 years ago and just, these are audio models. And there are specific science foundation models. And in science foundation models, there are multiple examples. For example, there are specific foundation models that are trained based on the structure, 3D structure of proteins that we call protein foundation models. You can give them a series of amino acids and they can give you the shape, the final shape of that protein, function of that protein. So based on the training that they have, you can give them new data and tell them, okay, now you learn all those 1 million proteins. Now if I give you this specific sequence, what will be the shape of that sequence? So this is called protein foundation models. And now we have brain foundation models. And brain foundation models basically learn from all the data that we have in the field of brain and neuroscience and use that information to give you ideas about how one single brain is functioning. And there is a very new one that was published just a few months ago. It's called NeuroStorm. Has anybody heard about NeuroStorm as a brain foundation model? Okay, so as I told you, early traditional methods like kind of Fourier transform, power spectrum analysis, and then machine learning methods like support vector machine, random forest, all those things that we have in machine learning, right? And then deep learning tools, different versions of deep learning tools in kind of 21st century, and then new series of brain foundation models. The first one started in Stanford, 2023. Few new ones in kind of over the 2023, and then many of them in 2024, and now in 2025, there are many of them. Many of them are developed in China, in the US, around the world. It's just global contribution. And each of them have a specific use. There are a couple of them that are focused to EEG data. There are a couple of them that are focused on animal data. It's just different. So there are tools to learn from the data is available and give you understanding about that data. And this specific one is called NeuroStorm that is recently published. You can find that here in the QR code. They trained it with whatever you have in UK Biobank. You know what is UK Biobank, right? So it's a huge database, and UK Biobank has a large brain imaging component inside. So in UK Biobank, we already have 40,000 brain scans in UK Biobank, okay? So they trained that using the UK Biobank. ABCD is a project in the US, and all the other major projects. So they trained the model with 70,000 people MRI scans, over 10,000 hours of MRI and fMRI. And this is and healthy people with kind of male and female children, adults, different databases, 72,000 participants in that large database. And they tested that model recently on some of the major questions that we have in the field in terms of, for example, based on an image and an fMRI activity, can I see just an fMRI activity and based on the fMRI activity of somebody, predict that what is the thing that they are seeing right now in front of them? Do you see what I mean? I'm looking to your brain. I do not know what you are seeing right now. Based on your brain activation, I can tell you that you are looking into fruits, or you are looking to this, or you're looking to that. Okay? So these are different types of questions like this one. And they showed that this new NeuroStorm model, this is the performance of the NeuroStorm model outside, is outperforming best models that we have developed before, significantly, on all those types of questions. And it is just mind-blowing in terms of how these models are able to function much better than whatever we developed before, and it's just moving forward. And now we are using that on what we call multi-level data fusion. And what do we mean by multi-level data fusion? In multi-level data fusion, we can even combine animal data with human and put all those brains together. So merging mice, rat, primates brain to human, and just projecting those databases on the same space and use that data together, which is fantastic to see. And now we are using that for what we call digital twin brain. So we have a trained model with 70,000 patients, and that now we can scan your brain, and then based on the limited data that we have in your brain, develop a digital version of your brain, and then use the stimulation for that specific digital brain, and see what is the optimum way of doing the stimulation. And after finding and testing those hypotheses in your digital version of your brain, then bringing that to your brain to use it in your brain. So this is the future of the field and how the field is moving forward. So the last slide. So this is how neuroscience is going to reshape the future of addiction medicine. And it's a very exciting field for all those new people, young people who are in the room. So the future is very, very bright. So there are lots of opportunities. So this is one of the papers that we wrote with Alex in terms of how neuroscience could be a part of addiction medicine innovation. We developed a network of experts, over 1,000 experts from 100 different countries that are working together on these ideas and collaborating together in a global level, and some take-home notes. So today we discuss about discovery, creativity, and invention, okay, and the importance of that. We discussed about addiction neuroscience in discovery and creativity and invention innovation. We discussed about gaps and needs to start innovation. We discussed about why. So needs are important and we need to consider them. And then how we can address those needs with the innovations that we have. And as I told you, there are huge gaps. Even, in the US alone, we lose 100,000 people every year on just drug overdose. Young, beautiful souls, 100,000 every year on just a drug overdose. So the need is huge and the gap is huge. But the voices to be heard, stakeholders, and I'm sure that Supriya is going to discuss about those ideas, and people with lived and living experience. Nothing about us without us, and that is very, very important. And co-invent innovation and co-development with those communities. And those who want to develop their future in this field, the potentials are fantastic. So I just would like to encourage young, brilliant minds that can see in the room, the future is bright for you. If you invest your life in these areas, it's going to be fantastic. And many thanks to my kind of lab members and my collaborators. And I'm really happy that we have this opportunity to further discuss this today. Thank you very much.